Okay, it seems to be live. Good
Yes,
day,
it is.
guys, and welcome once again to Africa Teen Geek Online School. My name is Nonkululego Madondo, and this is your Physical Sciences Grade 11 class. I hope you guys are having a great day. I'm having a great day, even though I managed to get in late, a couple of jibbies, but I hope that you guys are all ready to learn. And thank you so much to Mickey yesterday for handling this lesson, and she told me that she gave you guys homework, and I hope that you guys did that homework because I've got all the answers for that homework today, and we'll be going through that as well. But nonetheless, I hope that you guys are good, are having a great day. My name is Nonkululego Madondo, and this is your time. The topic for today is chemical change, molar volume, and gases. But before we go to that, I just want to I just want to share with us some of the solutions from some of the solutions for some of the solutions for yesterday's problem. I'm just trying to go through it quickly. Here it is, homework. It's just loading a bit. She told me that you guys were supposed to do number 4 and number 6. So I've got the solution for you guys. And I hope this was kind of easy for you because, if you just follow this step, I know it's a bit confusing when you're thinking of the two different methods, the empirical and the molecular. I know it's very difficult if you don't understand it, but I hope that these steps that we're going to go through will make your life a bit easier. Just waiting for it to load. Um, yes. Can everybody see this? Um, I hope that everybody can see it, but it's not opening up. I don't know what's
We
going
can
on.
see your document screen at the moment.
Yes?
We can see the list of all of your documents at the moment.
Oh, okay. Thank you so much. Let me try
Yeah.
and get through it. Uh, New slide. I'm looking for the picture, but it's also not loading. You know what I'll do? Let's just carry on with the lesson. I might have to show this later because I don't want us to waste any time, as time has already been wasted. But let me see, try one more time and see if I'm just trying to share. Okay. Um, Nonetheless, I'll get back to that. For now, however, I want us to just have an outline on all the things that we're going to be doing today. We'll get back to the homework later on in the show. For now, I just want us to do an outline of all the stuff that we're going to be doing today. We're going to be doing the molar volume and gases. That's our topic for today. Balanced chemical equations. We're going to learn to do that. Volume of gases at standard temperature and pressure, and volume of reactants. Sorry, that's a spelling mistake on my side. Um, Volume of reactants and products under the same condition. So those are the things we're going to be doing. And this is, I think, unit 3. Yes, this is unit 3 on your Oxford Successful book. That is a textbook that I'm using when I'm teaching. So you can try and get yourself the textbook. You can get it on Snaplify, you just register there and you can actually get a lot of textbooks for free. These people have actually made this service free for us for the entire year. So whenever you get a chance, you should go to Snaplify and get yourself some textbooks. I'm also using a bit of Siavula textbook. That's another free textbook. You can also get it on Snaplify, but you can also download it from Google, absolutely free. It's a good textbook and it talks about all the modules that we are doing. So I'm quickly going to go to our textbook that we're going to be using today, the Oxford. Okay, can you guys all see it? Okay, this one we're going to do this problem just after the lesson, but for now, let's just see the next topic. Okay, the computer is quite slow. I don't know why, but nonetheless, we can continue. I think I'll start just by introducing it. Molar volume of gases. It says a stoichiometric calculation begins by writing a balanced chemical equation for the reaction that takes place. So basically, what this means is that this is all about balancing equations. That's what we're going to be doing. And uh, yes, balanced chemical equations. That's the first topic we're going to do under this unit 3. In order to balance chemical reactions, take note of the following. Reactants appear on the left side and products appear on the right side, which is the right side of the arrow. And the states of reactants and products are written in parentheses to the right of each compound. For example, you'll see the small little sub symbols. S is for solid, L is for liquid, and G is for gas, and AQ is for aqueous gas. Okay, so coefficients are inserted to balance the equation. The number of particles on the left must be equal to the number of particles on your right. What does this mean? It means that, for example, I remember I once given you guys an example that basically what this means, it means 1 plus 3 must be equals to 2 plus 2. So they both equal to 4 on each sides, but in different ways. You always have to balance them. They always have to be balanced. And that's what we are going to be doing here today. So checking out an example here, we've got a table. If you look at this table this side, it shows a chemical reaction. The chemical reaction is for CH2H8 plus 5O2. They both gases. The G stands for gases. These are the sub that I was talking about there, that uh, the parentheses to on the right of each compound. For example, S is for solid, L is for liquid, G is for gas. This is a part that I'm emphasizing on. Yes, this one. This is what they mean. They always stated at the bottom what each stands for. Okay. So then we look at the next line on the table. It says amount in mole. Okay, another thing that I want you guys to know, by mole, they mean the numericals. Like, for example, what stands if there's a number before whatever derivative that you have. For example, here you see it's C2H2, but there's no number this side. So it means that it's a 1. And for this one, we've got a 5, which means it's 5 moles. So everything that stands in front of your elements is what is the number of moles for each. So that one is also important, and you must also bear it in mind. But I know you guys have also used it a lot when we did the previous exercise, and which we'll also look at later on. And then we go to number 3, the molar mass. The molar mass in gram per mole. This is what you get from the periodic table. Yes, This is what you get from the periodic table, and they just write it in there. And then the mass in gram. The mass in gram is what is given here, 440, 160, 132, and 72. What you get from this, when you total it, the mass in gram, it must be equal on both sides to show that your equation is balanced all the time. This is how it has to work. So you calculate your mass. I mean, if you've got your molar mass and your mole, you can always get your mass. Remember how we do that? It's the N is equals to mass divided by molar mass. So you can use that to get your mass. You'll just make mass the subject of the formula. So that's how you get to these answers that you have here. And once you have that, then you can calculate the total masses of each. And they have to be equal in order to show that your sum is balanced. Okay, moving to the next one. Balance the following equations. Um, Okay, this is activity one. I think there is some of them that I did do. Can you just give me a minute to show you guys in order for us to just have a bit of examples to what we are doing? Let's see. Okay, I just saved them in pictures today because my scan was giving me a problem and I couldn't scan them. So I'm taking them from pictures. I just took pictures just for you guys to have the example of each. So I'm just waiting for it to load. So it's quite, simple to do. The only thing you do here, it's pure maths. If there's two ends, there has to be two ends on the other side. So if you look at this problem on activity one, this is N2 plus H2. And another thing that I want to tell you guys, what N2 and plus H2 means basically is that nitrogen gas and hydrogen gas. Whenever you get a question that says nitrogen gas, you already know that it's N2. Whenever they say hydrogen gas, you know that it's H2. So, because sometimes I know they can give you a problem without giving you um, uh, the sum in numerical form. So they can just say nitrogen gas plus hydrogen gas gives you ammonia. This is a symbol of ammonia, and you're going to have to figure it out because you are a scientist. So when they give you these two, you already know this is how the equation is. But if you look at this equation is not balanced. That's where you come in. You have to balance this equation, and that is what this is about. Let me just check this. I'm trying to load the problems. I'm trying to load the problems because I did some of these activity problems and I'm just having a hard time getting to open them. But just a little time, we will have them ready. So for now, you can try and balance them out, and let's see if you'll be able to do some of them. You can start with the first one. Let's see if you can balance those equations while I try and open it up on my side because I have done some of them and I wanted to share them with you guys so that you can have an idea of what it means to balance each equation. Uh, okay, okay, back to this. Okay, then we're going to follow through. Okay, number one, if it's N2 plus H2 giving us HNH3, what does it mean when we're going to balance this equation? It means that basically you can only balance it by adding the number of moles. That's the only way you can balance an equation. You can't change the subnumerals that are given there to you. You can't change them. So it's always going to be a case that you have to it's always going to be the case that you have to balance them out on your own. Um, okay, my picture doesn't want to open up, so I'll just continue and you guys can follow through what I'm saying. Okay, okay. So how we're going to balance this? What we can do is that, okay, the N2 is fine because it doesn't have anything added on the other side. But for the H2, we can add a 3 to make it 6 so that it can balance out with the 3 on the other side. And then when we check the NH3, what we can do there, you can just add a 2 in front. Then try that quickly and see. You'll see that it balances out because now it means the N2 stays the same. There's two nitrogens. And then for the H2, it will equal to 6. And then when you go to the other side, because we added a 2, NH3, N is going to be 2, and the H is going to give us 6. So basically there, our our equation is balanced. Did you guys try that? I hope that you guys got it. If somebody didn't get it, you can send me a chat and just let me know where you're getting stuck, and we can take it on from there. And then we can also do number 3. Number 3 is Mg plus O2. We'll give it MgO. What we're going to do there is we can add a 2 on the Mg, and then on the product, we can just add another 2 there, and it'll be 2 MgO. And on the other side, we'll just have 2 on the Mg, and then that will be balanced. If I'm leaving you behind, drop me a chat, and I will try and see how I can go back and explain something to you. And then going to number 5. Number 5, we've got C3H8 gas. So there, what we can do, you can add the 10 to the O2, ne? And then on the other side, we can add a 3 on the carbon dioxide, the CO2, plus we can add 4 to the H2O. So in that way, it will be balanced, because if you check, we're going to have 3 carbons, and we've got 3 carbons on the other side. And then the H's, we've got 8. On the other side, we added a 4, so times H2 is going to be 8. And then plus the 10O2. 10O2. Oh, no, 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 no. Sorry, that's a mistake. It should be 10O2. Yes, 10O2. Then there we're going to have 6 from the O2 of the carbon dioxide. Remember, we added a 3 there. So it's going to give us 6 oxygen plus 4 oxygen, and that will give us 10. So now our equation is balanced. If I'm leaving you behind, please let me know. But I really hope that you're understanding what I'm saying. And then I tried to do the number 7 as well. One that is given, like I told you guys, they're not always going to give you straightforward equations. Sometimes they'll give it in words, and somehow you will have to know what each word means. So for number 7, it's KClO3, basically. That's potassium carbonate. It's KClO3. And then what is happening there? Um, it gives you KCl plus O2, because they said they want a result that can give you potassium chloride. So potassium chloride is KCl, and oxygen is O2. So what we do there, on the KClO3, we add a 2 in the front, yeah? And then on the KCl, we add a 2 in the front as well. But on the O2, we add a 3. So that will balance it out, because we'll have 2 Ks, 2 Cl, and 6 Os. On the other side, if you check again, you have 2 Ks, 2 Cl's, and 6 O's. So our equation there is balanced. I hope that everybody is understanding what I'm saying. But if you don't, be sure to send me on a chat and let me know. But now we're going to continue. Volume of gases at standard temperature and pressure. Equal volumes of gas at the same temperature and pressure contain the same number of moles or particle gases. Also, 1 mole of any gas at STP occupies a volume of 22.4 dm cubed. So that's the standard um, pressure. It's 22.4 dm cubed. This is called molar volume. This is the volume, the standard volume, the STP volume. And STP means standard temperature and pressure. Standard temperature is 273 K or degrees Celsius, 0 degrees Celsius. Remember, when you convert from degrees Celsius to Kelvin, you have to plus it by 273. So that's why it says 273 Kelvin in brackets 0 degrees Celsius. And the standard temperature is 101.3 kPa at 1 atm. And you must remember this all the time because we're still going to use it further in the problem that we're going to be doing later on. Okay, for those that have just joined in, I am right here. We're doing volume and gases now. So to calculate the volume of a gas at STP, V is equals to N times Vm. Okay, N is the number of moles of the gas, V is the actual volume of the gas, and Vm is the molar volume of the gas at STP. So what does this mean? It means that, for example, the Vm is constant. We already know it's constant. So Vm will always be 22.4. The only thing that will change in this case is the N. If, for example, they tell you 2 mole of chlorine gas, then you're going to say 2 times the 22.4 and it'll give you an answer. So that is always the case. Whenever they ask you to calculate the volume at STP, you know that you just need the number of moles and the Vm is already there. So there's an example there. You can see it says N times Vm, 2 times 22.4, it'll give you 44.8 dm cubed. Determine the mass of 60 centimeters of ammonia gas at STP. So, for example, whenever they give you something in centimeters, you know that in order to convert from centimeter to dm, you must divide it by 1,000. That's the first thing that you have to do all the time. Always make sure that your standards are in dm cubed, because that is what we're working with. You always have to convert it. Even if they give you in meters, then you know you must divide it by 100. If they give you in centimeter, you divide it by 1,000. But always change it. Don't just take it the way it is. Okay. Then from the volume, you're going to say V is equals to N over Vm. And that one is simple, as you've already mentioned. There you get your number of moles because it said determine the mass. Remember, as you can see, as we work through, everything is building up. The N is equals to M over capital letter M. That is already equations that you've learned in the previous sections in the past few days that we've been working together. So you can now get the number of moles and then you can calculate it. And from that, now you can go to the number of moles is equals to mass divided by molar mass. Molar mass, like I always keep telling you guys, always know and stick it in your head that molar mass is always what you go and look for in your table in order for you to get it, and you calculate it. So what did they do? They took nitrogen plus 3 times the hydrogen atomic mass, and they added it together, and that gives you 17.03. So what is nitrogen? Nitrogen, I know it's 16, and no, I don't think it's 16. I think it's 12.0. Okay, I'm not sure about that because I'm not holding my periodic table. But be sure that you guys always have your periodic table, because your periodic table is what is going to show you all your answers and everything that you need to know. Okay, and this is how we get our mass in grams. It's going to be 0.046. Just like that, you've given yourself probably about 6 marks, and It's so simple, this problem, but you guys need to always keep practicing. Okay, so moving on. Okay, moving on. We're going to volume of reactants and products under the same condition. Volume of reactants and products under the same condition. What does this mean? This means that there is a direct mathematical relationship between moles and volume of gases at the same temperature and pressure. So which means that STP, there's a relationship between the moles and volume of the gases. So here we get to introduce the Avogadros law of volumes and gases, which states that equal volumes of gases at the same pressure and temperature contain equal amount of molecules. I don't know if you guys understand this. They say Avogadro's law of volume states that the equal volume of gases at same pressure and temperature contains equal amounts of molecules. For volume under the same temperature conditions and pressure, V1 over N1 is equals to V2 over N2. So basically, this means that because V is equals to V1 is equals to V2, N1 is equals to N2. So this is at STP. Always at STP, you know that the temperature and pressure is equal. So which means this is the only time that this um, Avogadro's law of volume of gases applies to. So if you are given volume of one gas, you can find the volume of the other gas in the reaction by using the relationship between moles and volume of gases to calculate, balance the chemical equation, use the mole ratio of two gases to find unknown volume. Okay, so as we've got an example here. I'm not sure if you guys can see it properly because I can't zoom into the screen. So here they say in the process. If 500 react, calculate the following. Calculate the following and the volume of hydrogen gas that is produced. So what does it mean here? Already they've given us the V of nitrogen. And remember what they said, if you have one volume, it means you can get the other one. And number two, one thing you have to do, you have to balance your equation. You have to write a balanced equation in order for you to know your number of moles. Here you can see they say nitrogen gas plus hydrogen gas. Remember what I told you earlier on? Whenever you hear nitrogen gas and hydrogen gas, you know already it's N2 plus H2, nothing else. Is equals to NH3. Ammonia is always NH3. These are some of the things that you have to know by heart because you might not get it in the exam and you might have to know that on your own. So now you've got those ones. So now you have to balance them before you do anything. They have to be balanced. So what have they done here? On the 3, they've added a 3 on the hydrogen and added a 2 on the ammonia. If they do that, then our equation is balanced because on NH3, if you add 2, we're going to have 2 nitrogens and 6 hydrogens. And then for the other side, the reactant side, we've got N2 already, and we added a 3 on the hydrogen. So it's going to give us 6. It's going to give us 6. So everything now is balanced. And then when we check the number of moles, okay, let's start with the nitrogen. How many nitrogen number of moles do we have? We have 1 because there's no number in front of it. And then for hydrogen gas, we've got 3 moles because we've got a number 3 in front of it. And then for ammonia, we've got 2 because we've got a number 2 in front of the ammonia element. compound, I meant to say. So now we've got everything in check. So now we're ready to calculate for our volume. So we're going to start with the ammonia one. V1 over N1, div- uh, V1 over N1 is equals to V2 over N2. What that simply means, okay, the volume one is for the nitrogen. They've already given us 500 for the nitrogen, and we divide that by 0, because if you check here, N2, it's 1. So which means the number of moles will be 1. That's why we see a 1 there. And then the volume for ammonia, because that's what they want in the question, is the one that we don't have. But for ammonia, we've got 2 moles. So our N is equals to 2. Hence, you see a 2 here. So just by this, we can simply do a simple substitution, cross multiplication. You'll say 1V1 times 500 times 2, and that will give us 1,000. So which means it's 1,000 cm cubed of ammonia gas is produced. Okay. And then when we go to the hydrogen gas, we're going to also do the same process, but this one you can do on your own. So the volume of reactants and products under different conditions. If the pressure or temperature changes, then the volume of the gas will change. The gas law for different conditions were discussed in Module 4. The two gas laws are used to solve problems where reactants are under different conditions. So I hope that that have given you guys more details on what we are doing. So for tomorrow, obviously there's homework. Our homework for tomorrow is choose the correct answer. Let me see. Let's do the even numbers. Yes, let's do the even numbers, which means we're going to do 2, we're going to do 4, and we're going to do number 6. And then we'll try and solve those problems tomorrow. But for now, quickly, I just want to go back. I just want to go back into the picture that I wanted you guys to see. I'm still trying to load it, and we're so running out of time. I can't seem to find it. I'm looking for the picture. I'm looking for the picture of the answers. It's not giving me enough information as I'd like, because I took a picture of it, but now I can't seem to disperse it. So I'm trying another way to get it through the exam. Guys, please do these problems, and please don't be afraid to let me know if you can't find me. You can also email me on t33t@gmail.com if you guys have further problems that you want explained to you guys. I'm here for you guys to help you guys, and we can go through it and see it. But I really hope that today's lesson was very effective for all of you guys, and you understand now more or less the molar mass and gas and volumes problems, as we've done a couple of examples today. I hope that you guys have a bit of a clear understanding on what is going on. But for now, I just want to get us the homework. Our homework from yesterday, the answers, because I know that you guys might need it. Um, I'm just trying a different way for me to load them up because they don't seem to appear on my computer. But thank you guys so much. Thank you guys so much. You guys have been really appreciated, and I thank you guys so much for staying tuned into my program and being here and doing physics for the love of physics, guys. I'm just trying to get the homework picture so that I can give it to you guys. Yo, but it's so not visible. Okay, let me see if I can get it for you guys now, just before we leave. Just before we leave, I'm going to share it in the next few seconds. Okay, here it is. Okay, can you guys see it? Can you guys see the answers? I'm not sure if everybody can see if it's showing, because I did share it, but I'm just not sure if it's showing.
We can only see your Google Drive.
Oh, so you can't see the, that means it went to the wrong place. Oof. Okay, you know what, guys? I will try and PDF it tomorrow, and then which means tomorrow I'll be showing answers for that activity and tomorrow's activity. But nonetheless, guys, can you please do the problems, because this is going to help you, and in that way we can move forward with chemistry. Like I said, I'm doing a unit a day just to make sure that everybody understand what is going on, and after that we'll be able to move on. So tomorrow we are doing the next lesson, and that will be module 3. And in module 3, please try and get yourself the Oxford textbook if you don't have it, or if your textbook goes hand in hand with what you're doing, just go through the stuff and let's do it and see how we can, because it's always good to be prepared when a lesson starts. So tomorrow we're going to be doing Unit 4, stoichiometric calculations with mass, volume, and number of particles. So that is what we're going to be doing tomorrow. And you guys can go through some of those problems, because definitely there'll be homework again. And after that, we'll be good to go. Thank you guys so much for the lesson today. Thank you guys for being the best team ever. And I'll see you guys tomorrow. Thank you. Bye.